Hey guys! Today's lesson is on solving equations as well. It's just the two-parter. So it's a second part to solving equations, and this is solving equations by balancing. So this is where I was talking about the balance beam in class a couple of times, and if you can see my beautiful drawing before your eyes, it looks exactly like a balance beam. All right, so first we have to figure out what equation is this balance beam representing. And these little brown sacks over here on the left-hand side are, that's exactly what they're meant to be. They're meant to be bags. So there's n amount in each bag. We don't know how much is in each bag. We just know there are 3 bags. So that gets represented as 3n because we don't know what's in each bag, but we do know that there are 3 bags. Plus the 2 red counters on the left side as well. That gets represented as plus 2 equals. And then we look at all of the counters on the left-hand side. So this is kind of like left-hand side, right-hand side. We look at all the counters on the right-hand side. There are 17. So that's why the balance beam is exactly equal, because the left side is not higher or lower than the right side. So 3n plus 2 is going to equal 17. Well, what we're going to do is, the way they do it in the textbook is a little more confusing. They like to show that when you're bringing the 2 over to the other side, we did that in class today, it becomes the opposite. It becomes, because it was plus 2 on the left side, it becomes minus 2 on the right side. They like to show it in the textbook as, like to represent it like this. So plus 2, and they like to do the same. Whatever's on the left side, you do to the right side. So that it would be 17 minus 2 on this side. I think that tends to be a little confusing, so I don't like to represent it on the left side. I just like to represent it on the right side. But basically what I've done is I'm erasing the two counters on the left side, and then I'm also taking 2 away on the right side, because whatever you do to the left side, you have to do to the right side to make it balanced. So that's why you see the 17 minus 2 on that side, and technically we could have a little minus 2 on this side. Anyways, and the next line would be 3n equals, and then you do solve the 17 minus 2 because we've taken 2 away, which leaves us with 15. Sorry, I had to pause the video because the bell rang and now I don't remember where I left off. So I think I was saying that now we're left off with 3n equals 15. So again, if we're looking at the 3n, that's equated with multiplication. So what we do to the left side, we have to do to the right side. So if we want to divide these 3 bags by 3 on this side, then we have to do the same and divide these 15 counters by 3 as well. So what you would do is you divide these 3 bags by 3, which leaves 1 bag per person. Okay, so that's why you are left with n bag, only 1 bag. Technically, this could be 1n equals. And then on the right side here, you would have divided 15 by 3. And then that would give you n equals 5. And if we're going to check this, that means that there are 5 counters in each bag. So then if we want to go back and check this, I'm going to do it up at the top here in blue. We do 3. Now that we know n equals 5, you substitute in 5 plus 2 equals 17. 3 times 5 is 15 plus 2 equals 17. So we know that we're right. I'm going to do another example. All right, so looking at the balance beam here, I want you to think about what equation this could be. So remember, left side equals right side. So we have 2 sacks here. Again, we'll put little ends on them because we don't know how many there are. There are 2 of them. So we're going to put 2 there. We don't know what's in each one, so that's why we go 2n, because we need to find out what n is. And then we have 3 counters beside it, so that's going to be plus 3. Equals, and then we're going to count the number of counters on the right side here, and there are 9. So now we know the equation is going to be like this. So now, technically, we have to balance the beam out, okay? And we have to also isolate n. So we're going to first take care of these counters. So the counters on the left side, we're going to take them away. Okay, we're also going to take them away on the right side. Okay, so technically we could do this because we took them away on the left side. And now we're going to have on the right side 9 minus 3. And because we took them away, now in the third step here, we just have 2n because we took the counters away, and all that we're left with is this sack. So we have 2n, and then we're going to solve 9 take away 3, which is 6. Okay, and now we're going to attack the sacks here. And because the 2n is equated with multiplication, now we're going to have to do division. So we're going to have to divide these sacks by 2, and that means each person gets 1. So 2 divided by 2 is 1. So we're just left with the n. So again, we could do this on the left side, and then we bring over divided by 2 to the right side. And then the last step would be we've isolated n, and then we do 6 divided by 2, and that's going to give us 4. So basically the balance beam is, very similar to what we did today when we isolated the variable, but it kind of shows you why it flips to the opposite sign when it crosses the equal sign. It's not that it magically flips, it's that we're balancing out the equation. So what we've taken away or what we've divided on the left side, we also have to take away or divide or do whatever to the right side. So it kind of gives you a more visual representation of how isolating the variable works. So again, if you don't understand those two examples, please watch them both again because I am going to get you to do the key assessment question now. And like I stated in the instructions, the key assessment question is the picture that's attached to this particular assignment that I put up on Google Classroom. Alrighty, see you tomorrow.